primary protector is a device that offers the first line of defense against overvoltage events. Typically, it's positioned where the utility power line enters a building, such as at the meter or the service entrance panel. Article 800.90 covers all low-voltage communication wiring within homes, encompassing phone lines, cable television wiring, and audio/visual components. If you have larger/V component racks and lighting control panels in a basement, these are generally considered low-voltage communication equipment, meaning Article 800.90 applies. Section 800.90b mandates that all exposed conductive parts of low-voltage communication equipment must be connected to each other and to the building's grounding system. This system commonly features firstly, a grounding electrode system such as a ground rod or metallic water pipe. Secondly, a grounding electrode conductor, which is often a bare copper wire. Thirdly, an equipment grounding conductor, typically a green or bare copper wire. Connecting all racks and panels using a number 6 copper wire, and then running it to and attaching it to the grounding electrode that connects to your distribution panel is an acceptable way to bond the equipment according to Article 800.90b. Keep in mind that the primary protector that's installed by the utility company might not be enough to fully protect your low-voltage communication equipment from overvoltage surges. You might need to add extra surge protectors. It's also crucial that your grounding electrode system is adequately sized to manage any potential fault current coming from the low-voltage communication equipment. Be sure to check Article 800.90 for more in-depth details about bonding and grounding requirements. Here's a breakdown of key concepts to help understand these requirements better. Firstly, grounding ensures a safe path for electrical faults to return to the source, tripping circuit breakers and preventing electrical shock hazards. Secondly, bonding connects metallic parts to create a low impedance path for fault currents, minimizing voltage differences and reducing the risk of electrical shock. Thirdly, surge protection devices to avert transient voltage surges away from sensitive electronic equipment, protecting them from damage. In the context of low-voltage communication wiring, these measures work together to protect equipment and people from electrical hazards. When considering grounding, understand that a grounding electrode system is a network of interconnected grounding electrodes designed to provide a low-resistance path to earth. Common types of grounding electrodes include ground rods, metallic water pipes, and ground rings. The grounding electrode conductor connects the grounding electrode system to the service equipment or separately derived system. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. An equipment grounding conductor provides a low impedance path for fault currents to return to the source. It is typically a green or bare copper wire that runs along with the circuit conductors. Now let's elaborate on bonding. Bonding jumpers are used to connect metallic parts of equipment together to create a low impedance path. Bonding ensures that all metallic parts are at the same potential, reducing the risk of electrical shock. The size of bonding jumpers is determined by the size of the circuit conductors. Bonding bushings are used to bond conduit to enclosures, ensuring a continuous electrical path. Bonding lock nuts are used to bond conduit to boxes or enclosures. They provide a secure connection and maintain electrical continuity. Finally, consider surge protection. Surge protection devices, or SPDs, are designed to protect electronic equipment from transient voltage surges. SPD divert surge current away from sensitive equipment, preventing damage. SPD are typically installed at the service entrance panel and at individual equipment locations. There are different types of SPD, including Type 1, Type 2, and Type 3 SPD. Type 1 SPD are installed at the service entrance and provide the highest level of protection. Type 2 SPD are installed at distribution panels and protect branch circuits. Type 3 SPD are installed at individual equipment locations and provide localized protection. Selecting the right SPD depends on the specific application and the level of protection required. When installing low-voltage communication wiring, it's crucial to follow all applicable codes and standards, including the National Electrical Code, or NEC, and local building codes. These codes provide detailed requirements for grounding, bonding, and surge protection. Proper installation and maintenance are essential for ensuring the safety and reliability of electrical systems. When installing grounding systems, follow these guidelines. Choose appropriate grounding electrodes based on soil conditions and local requirements. Ensure that grounding electrodes are installed deep enough to reach permanent moisture. Properly connect grounding electrode conductors to grounding electrodes and service equipment. When implementing bonding, use appropriate bonding jumpers and connectors. Ensure that bonding jumpers are properly sized and installed. Maintain continuous electrical continuity throughout the bonding system. When it comes to surge protection, select SPD that are appropriate for the specific application. Install SPD in accordance with manufacturer's instructions. Regularly inspect SPD and replace them if they are damaged or expired. Remember to consult with a qualified electrician or electrical engineer for assistance with complex electrical installations. They can provide expert guidance and ensure that your electrical system is safe and compliant. Let's delve deeper into specific sections of Article 800 and their implications for your installation. Section 800.44 covers the separation of communications wires and cables from other conductors. It specifies the minimum distances required between communication cables and power conductors to prevent interference and ensure safety. Section 800.50 addresses the installation of communication cables in raceways. It outlines the types of raceways that are permitted for communication cables and the requirements for cable fill. Section 800.52 covers the support and securing of communication cables. It specifies the methods for supporting and securing cables to prevent strain and damage. Section 800.100 provides requirements for the protection of communications equipment from lightning. It specifies the types of surge protection devices that are required and the methods for grounding and bonding. Section 800.133 addresses the marking of communications cables. It requires that cables be marked with the manufacturer's name or trademark, voltage rating, and other relevant information. Consider the types of communication cables you are using. There are various types of communication cables available, each with its own unique characteristics and applications. Coaxial cable is commonly used for cable television and internet connections. Twisted pair cable is used for telephone and data networks. Fiber optic cable is used for high-speed data transmission. The type of cable you choose will depend on the specific requirements of your application. Think about cable shielding. Shielded cables are used to reduce electromagnetic interference and improve signal quality. Shielding is particularly important in environments with high levels of electrical noise. There are different types of cable shielding available, including foil shielding, braid shielding, and combination shielding. Choose the type of shielding that is appropriate for your application. Also consider cable grounding. Cable grounding is essential for reducing noise and preventing ground loops. Grounding should be done at one end of the cable only to avoid creating a ground loop. The grounding conductor should be connected to a dedicated grounding point. Now let's talk about grounding electrodes. Grounding electrodes are used to provide a low resistance path to earth for electrical currents. There are different types of grounding electrodes available, including ground rods, ground plates, and underground metallic water pipes. The type of grounding electrode you choose will depend on soil conditions and local requirements. The National Electrical Code, or NEC, provides specific requirements for grounding electrode systems. These requirements vary depending on the type of electrical system and the size of the service. It is important to follow the NEC requirements to ensure that your grounding system is safe and effective. The grounding electrode conductor connects the grounding electrode to the service equipment or separately derived system. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The grounding electrode conductor should be made of copper or other corrosion-resistant material. The equipment grounding conductor provides a low impedance path for fault currents to return to the source. The equipment grounding conductor should be installed with the circuit conductors. The equipment grounding conductor should be sized according to the NEC. Bonding is the process of connecting metallic parts of equipment together to create a low impedance path for fault currents. Bonding ensures that all metallic parts are at the same potential, reducing the risk of electrical shock. Bonding should be done using bonding jumpers, bonding bushings, or other approved methods. Bonding jumpers are used to connect metallic parts of equipment together. Bonding jumpers should be sized according to the NEC. Bonding bushings are used to bond conduit to enclosures. Bonding bushings should be installed on both ends of the conduit. Surge protection devices, or SPDs, are used to protect electronic equipment from transient voltage surges. SPD diverts surge current away from sensitive equipment, preventing damage. SPD should be installed at the service entrance and at individual equipment locations. There are different types of SPD available, including Type 1, Type 2, and Type 3 SPD. Type 1 SPD are installed at the service entrance and provide the highest level of protection. Type 2 SPD are installed at distribution panels and protect branch circuits. Type 3 SPD are installed at individual equipment locations and provide localized protection. Remember that electrical safety is paramount. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow all applicable codes and standards. If you are not comfortable working with electricity, hire a qualified electrician. They have the knowledge and experience to perform electrical work safely and effectively. Proper grounding, bonding, and surge protection are essential for protecting people and equipment from electrical hazards. By following the guidelines outlined in this information, you can ensure that your electrical system is safe and reliable.